I thought it would be fun to do something a little different today and talk about what a huge failure I am. Have you ever done something so sincerely, so earnestly, and you shove it out into the world and 500,000 people watch it, and only 60% of people who watched it got it? Which means it was a failure, which means it was bad. You were trying to communicate an idea and it didn't work. How embarrassing for you. Publicly. 500,000 people is a lot of people. Yikes. So we're coming up on the 1-year anniversary of this video, and I thought it would be fun to do an analysis, a retrospective, and an autopsy of what a failure of science communication this was. Because as I said, only 60% of people, and I'll tell you how I got that number, who watched this video understood the video, which is of course my fault. I'm trying to communicate an idea and I failed. That was pretty bad. 60% is a failing grade. That's embarrassing. Okay, so let's give a quick summary of this video. I had to rewatch it obviously for this video, and that was horrible for me, but the video itself is fine. The sound is bad. It's hard to listen to if you don't have headphones. I'm sorry, I edit with headphones, so I thought it was fine. But the video is fine. All the science in it is fine. I understood what I was saying, but obviously that's not good enough because only 60% of viewers understood what I was saying. So I watched the video, and then I also downloaded all the comments, and I read all the comments. There was some weird stuff in there, but don't worry, it wasn't too bad because I block a lot of people. So there weren't any really bad comments in it. So that was fine. And then I sorted them into little categories. Yeah. A quick summary of this video, just in case you don't want to watch it. Although you should. I still think it's a good video. Anyway, it's fine. I wanted to talk about misconceptions people have about dark matter on the internet because I had recently started being on the internet talking about science, and I was like, whoa, people are very confused about dark matter. Maybe I can make a little video about it. Whew, you failed, Past Angela. Anyway, in this video, I list a bunch of different observations for dark matter. Because you see, dark matter is not a theory. Dark matter is a problem. It's a bunch of things we observe, a list of observations that we don't understand. You see, we have a model for the universe, and we can make predictions based on that model. And when we observe the universe, it doesn't match, which means that our model is wrong. There's a problem with our model. It's called the dark matter problem, and it's a list of observations. Of course, there are 1,000 theories of dark matter, and I didn't want to talk about a specific theory in that video because the problem of dark matter is independent of all the theories. The problem is a problem with our model. It's a list of observations that we cannot explain right now. It doesn't matter which theory of the many, many, many you ascribe to. That theory to work has to answer all these problems, all these observations. Well, one of the problems is that when people talk about dark matter on the internet, they only talk about rotation curves usually. And while rotation curves are a nice little observation of dark matter, it goes much, much deeper. Right? You have dark matter observations at all different length scales, at the galaxy scale, at the galaxy cluster scale, at the teeny tiny early universe scale with Big Bang nucleosynthesis and stuff. There are observations of this dark matter problem, all of these things that look like missing matter at all different length scales. And I purposefully didn't mention any theories of dark matter till the very end, because like I said, what's important is that all these observations have to be answered. It doesn't matter what theory you use. However, I did go through the general list. It could be a particle. It could be gravity being weird. It could be something we haven't even ever guessed yet. Do you know what I mean? So that's the video. The video was to highlight all the different observations of dark matter so that you have a better picture in your mind when you start reading popular science news about dark matter. It didn't work though. So let's get into some of the failures. I'm going to share the biggest failure first, which is my super secret reason for making that video. Okay, This is so embarrassing. When I made this video about a year ago, it was because I had just started talking about science on the internet. And I'm a dark matter guy. That's my background. I don't do that now, but I guess now I'm an amateur dark matter guy, which is kind of fun. But I spent like 10 years in the field, right? Okay, so when I started talking about dark matter on the internet, I learned that a lot of people think MOND is not only a leading theory of dark matter, but it's like the most mathematically rigorous. And I was like, oh no, that's not true. Like when you go to a dark matter conference, there's like 400 people there and they all work on all different stuff. You know, like, oh, what if dark matter's black holes? What if it's rogue planets? All that stuff, different particle types. What if dark matter doesn't even exist and all of our observations are wrong? Like that's a theory of dark matter, right? But at the dark matter conference where there are 400 people, there's like 3 MOND people. Okay. But when you go on the internet, it's a huge percentage of MOND people, which means that scientists are not doing a good job communicating to the public what the dark matter problem is, which is why I made a whole video about all the different scales we see dark matter at and why the problem is much bigger than like rotation curves. However, when I downloaded all of the comments and I found all of the ones that reference any theory of dark matter, even the ones that are like, I think all the scientists are just stupid. Like, that's a theory of dark matter, right? If you think every observation of space is wrong and that explains the dark matter problem, that's a theory of dark matter. It sucks, but that's a theory. So I took all of those comments, and there were like 1,000. And I made this plot like 2 days ago. And when I tell you how shocked I was, okay, I'm so embarrassed. Here's the plot. So in the video where I had the intention of convincing people that MOND is not a great theory of dark matter, 90% of the comments referencing a theory of dark matter were like, I think MOND's really good. What about MOND? MOND's the best theory of dark matter. It's the most mathematically rigorous. And there's no scale on this plot. So you might think like, oh, like 30 of the 900 comments said MOND was the best. That's 90%. 900 comments. Just what a blow. Maybe during the video I should have talked about how we observe all different types of rotation curves in different galaxies. And so you can't just fit a single curve and be like, oh, maybe dark matter changes with radius and it looks like this. Because then every single galaxy would have a different gravitational law. And that doesn't really make sense. I should have said something like that. Here is where one of the confusions about dark matter like appears. When this is presented as like rotation curves, galaxies are evidence for dark matter, it's often presented with a single plot. And I think that might lead some people to think that this is like a systematic error. Like, okay, well, if you get the same measurement in every galaxy, then obviously something is wrong with the way we're taking the data or something. But it's not true that we get the same curve in every galaxy. Like the amount of dark matter in a galaxy varies wildly. Like some galaxies have really small light mass and they have a whole lot of dark mass. There have been galaxies observed without any dark matter. Well, very, very little dark matter at all. Or I should have talked about how like, okay, if MOND works for rotation curves, fine, but it doesn't work for like the Big Bang stuff, the cosmology stuff. It doesn't work for the bullet cluster. And I know you can Google a paper that's like MOND for the bullet cluster. How many citations does that paper have? It's just this plot shook me to my core. What a failure I am. How? Like this plot needs to be studied. Like I'm gonna theorize. I think it's marketing. Okay. I think the reason MOND is so successful is because the 3 people who do MOND are really good at marketing. Okay, let me explain why. Okay, imagine you're BBC, the news company, and you call a physicist and you're like, hey, within 2 minutes, can you explain MOND? And that's really easy, right? You slap up this plot and you're like, here's what we expect and here's what we measure. Some scientists might think there's a bunch of invisible mass there, but maybe the way we think about this is wrong. What if gravity is just different and we fit a curve to this? MOND. And everyone's like, That makes perfect sense. Of course, there's not invisible matter. Dark matter is not invisible, by the way, it's dark. Of course, Mon, that's perfect. And that's what people see, and they're like, that does make sense. And it does. I agree. But what if you ask a second question? What if you give them more than 2 minutes? Like, what if you say, but what about those galaxies with like a lot of dark matter compared to their luminous light? What about those galaxies that don't have any dark matter? What about those? Do they have their own gravitational law? Do you just fit a curve to every single galaxy? What's your theory on why every single galaxy has a different curve for it? That doesn't make sense. You know? Or if you said, oh, then how do you explain like the WMAP data with MOND? How do you do that? And if you were to the commenters who like MOND and say that it seems like the most mathematically rigorous, if you had read a MOND paper, you would know that the majority of MOND papers also invoke particle dark matter to explain all the other observations. They're like, yeah, MOND at large length scales, definitely, but all this other stuff, it's probably like neutrinos or something, you know? Which means it's not a MOND theory, in my opinion. If it has a dark matter particle and then also MOND, it's a particle dark matter theory. So there's that, right? It sounds really good for the sound bite. It convinces the people because they only give them 2 minutes. And if you just tried to compare that to what a particle dark matter person would have to do, like a particle dark matter person would have to be like, okay, so you know quantum mechanics? Okay, so you know at CERN? Okay, so we have these cross-section matrices that we have to use to calculate the interaction between our hypothetical dark matter candidates, and the math is really hard, you can't do it, so we have to use this computer, and it's like they would be cut off. The problem is more complicated than rotation curves. That's why I tried to highlight it in the video. Like, yeah, rotation curves look like you could explain them away with, oh, you don't understand gravity, Einstein was wrong, actually. But that's not the only part of the problem. There's this huge problem. And MOND, I mean, it's still a theory of dark matter. It's totally fine. I don't want to shit on the 3 people doing MOND, but it's just so overrepresented in the public that it's shocking. Like, actually shocking. And that's the reason I made this video. I made this video specifically because I was like, wait, why is MOND so popular? Maybe someone needs to communicate how much more complicated the problem is than just rotation curves. That's so wild. Like, I don't even know if I can convey to you how weird it was. Like, imagine you're going to a Star Trek con and everyone is supposed to do cosplay. Okay? What do you think people will cosplay as? You know, Kirk, Spock, Data, Picard, the Borg Queen, you know, Janeway, like that type of thing, right? You would expect to go and see lots of different characters represented. But what happened to me when I started talking about science on the internet was I went to a Star Trek conference and every single person was dressed like Tam Elbrin, the Betazoid. And it's like, that's a good character. And I'm sure that's someone's favorite character. But how would 90% of the people at the Star Trek conference are dressed like that one guy from that one episode? It's shocking. It's baffling. How did this happen? That's what it felt like. The MOND is wildly overrepresented on the internet, and it's so interesting. I think it's because of marketing, but it's also a failure of people like me to accurately explain how complicated the dark matter problem is, how all these different observations happening at different scales just pull away from the idea that it just has to do with gravity, because it's not. Probably it's not, but I mean, it could be. Like, that's how theories work. But I just look at this plot and I'm like, ah, man, you failed. You tried to do one thing, convince people the problem is more complicated. And I guess I could have just directly referenced MOND and been like, it's overrepresented on the internet. Like, that is how I should have communicated it, like I just did right now. Like, it's not bad. It's just not even close to being the most interesting or most relevant or the most successful dark matter theory so far. Do you know what I mean? I could have just said that, but I wanted to lead the audience to a conclusion by presenting all the evidence, but it didn't work. It's weird to me that this is still a problem because there's an XKCD about this like 10 years ago. The same thing. Like 10 years ago. 10 years of this. That's on me though. Womp womp. So let's look at the rest of the comments. So what I did was I read all of the comments and I sorted them into categories. The first category is other. And the second category is completely misunderstood the video. That pie chart looks like this. Referring to the previous pie chart, if you left a comment and you were like, Mond is my favorite theory, I would put that in other, because like that's not an incorrect statement. That doesn't mean you got something wrong from the video. Like you can like Mond, it's totally fine. That's not wrong, right? It's okay to like Mond, that's in other. The ones that got the video completely wrong, I mean, we're gonna go through a breakdown category by category, but man, look at this. What a garbage human I am. I tried to explain something on the internet and 40% of the audience left with the completely wrong idea. Like, that's a failing grade. That's so bad. That's pretty bad. So, let's go through the categories of people who didn't understand the video case by case, and we'll try to, like, figure out what I could have done better. Because I do think this is my fault. Like, I tried to say something, and it was misconstrued. That's on the fault of the speaker. So as we go through, I'm going to try to pinpoint, like, what I could have done instead. Okay. Remember what this video is about. Dark matter is not a theory. It is a list of observations. There is something wrong with the way our model of the universe works because we don't understand these results. It is an open problem. It is an open question. Dark matter is not a theory. And this big old chunk of people said, actually, yes, it is a theory. Or I also included it in here if people were like, you're right. It's not even a theory, it's a hypothesis. So here's the problem, right? I listed all the observations of dark matter and I was like, open question, how exciting. And these people were like, how dare you say dark matter answers all those open questions when it's just that's the name of all the questions. That's what we call it because it behaves like matter and it doesn't interact with the electromagnetic force. So whatever that is, we just call it dark matter. And it's an open question. And of course, there are theories, but the open question alone is not a theory. And all of these people were like, yes, it is. So they didn't leave the video with that information. They started, I don't know, they were doing like 6th grade definitions of like, well, actually a scientific law is this. And it was really weird because they were all using the same language. And I realized that they had Googled like, what is a theory to try and like prove me wrong, but really they just misunderstood. So again, that is on me. Okay, so let me read you one of the comments that helpfully defines theory for us. Hi, Angela. Hi, Mount Space. I don't know what your scientific background is. I have a PhD in physics. It says on like my little channel name, but that's okay. But in science, a theory is not one of many possibilities. I don't think I said that it was, but thank you. It is, like others have told you in the comments, something well explained that has been tested countless times and confirmed by a vast body of evidence. Maybe you should rename your video Dark Matter is not just a hypothesis. So according to Mount Space, a theory is something that's well explained, has been tested countless times, and confirmed by a vast body of evidence. Great. So let's go through it. I was explaining the observations of dark matter. It's not well explained because, as I said in the video, we don't know what it is. It's an open question. It hasn't been tested because it's an observation. I mean, we've observed it a bunch of different times, but we don't know what it is. So we're not testing our idea of what it is when we see this observation over and over again. Of course, theories of dark matter would test their theory, because that's how you test a theory, but dark matter alone is a list of observations. It's not a theory, it's a problem. What was the last one? Something well explained that has been tested countless times. Yeah, it's not well explained because we don't know what it is, as I said in the video. But maybe I should have said that in the video, that we don't know what it is, I guess. The the cross-section might just be very small. It depends on what dark matter actually ends up being. Surprise, we don't know. Yeah. So, I mean, is this title clickbait? Is dark matter not a theory clickbait? Like, it makes people click, but it's not clickbait because it's true. Dark matter is not a theory, despite what all these comments say, even though they watched the video and they didn't get it. I mean, it is on me. Maybe I should have explicitly said, like, so the title of this video was not clickbait. Dark matter is not a theory. The title of this video references the observations of dark matter, the problem. We have a model of how the universe should look, and it doesn't match that, which means there's a problem with our model. We call that problem dark matter. Of course, we propose countless theories of dark matter, but none of them are good yet, okay? Dark matter is not a theory. It's not clickbait. That was the video. I mean, is it clickbait? It was intended to get people to watch it because I felt that there was confusion, and there is confusion about it. And obviously my video was a failure because it didn't explain it, because people left thinking it was a theory. I failed so bad. I'm so bad. But that was the point. The point was to show you that it is a list of observations. There are theories of dark matter, of course, but it's fine. It's fine. Get back to, like, what I could have done to fix this. I think maybe I said at the top, like, hey, the title's not clickbait, but I should have, like, very delicately explained, I know what a theory is. Obviously, I know what a theory is. You don't have to define it for me, but I should have said, this is what a theory is. Dark matter doesn't fit that because dark matter is a problem. It is not an explanation. It is an open question. Theories offer explanations. What I should have done maybe is compared it to string theory, because I had just made that string theory video where, like, string theory, is a mathematical model to explain an observation, but that's a theory. But dark matter is the observation. Dark matter is the problem. So it's not a theory, it's the problem. Dark matter is the problem. That's a t-shirt. Okay, I should have said that, I guess. Because it doesn't offer observations. And in the comments, a lot of people were throwing dark matter into the same pile, which confused me. Because I'm so sorry to say this again, but dark matter is not a theory. Dark matter is a list of observations. It is nothing like string theory. Again, I mean, I'm on the defense of string theory now all the time. String theory is trying to answer questions that we get from observing things, whereas dark matter is a thing we observe that raises questions and requires theories to explain. So of course there are theories of dark matter. Tons and tons and tons and tons of them is dark matter. A particle, is it a superfluid? Is it Newton's law of gravity depending on R? It's like R squared plus a little epsilon or something, and who knows? Lots and lots of theories. So let's move on to our second little slice of pie. Remember, in this video about dark matter, which was a huge failure, I tried to communicate that dark matter is not a theory. Dark matter is a list of observations that we don't have an explanation for yet. We don't have a good theory for this yet. We're trying to learn about it. It's an open question. We have a model that we think should explain how the universe works, but it doesn't. It doesn't work that way. There's a problem with our model. We call that problem dark matter, which is a list of observations. So the next group of comments are people who watched the video where I hope to convey all of that information, and they left a comment that said, I think there's a problem with the model.
They ask you how you are, you just have to say that you're fine when you're not really fine, but you just can't get into it because they would never understand.
Yep, that's the thesis of the video. Okay, I have to explain to you something about YouTube if you don't know. So I didn't know this going in, but a lot of people summarize a video and leave a comment as if they're contributing a unique thought. And there's nothing wrong with that. They might be doing that for the algorithm, like to give like a boost. I think comments are good for the algorithm. I don't really know. But it's really jarring as someone who like made a video. Like I made a video trying to say, dark matter is not a theory, it's a list of observations, it's just a huge open question. And there's a problem with our model of the universe. And then I open my phone and I see comments that are just like, well, I think maybe there's just a problem with our model. And it's just like, yeah. I mean, so maybe there's a group of people who are in this little pie chart and they did understand the video and they're just leaving like the thesis of the video in a comment, which I don't understand, but maybe that's true. But I would argue that a huge percentage of people who left the comment, I think there's just a problem with the model, think that they are disagreeing with me, which means they misunderstood the video, which is of course my fault because I did not communicate my point properly. Like, there's always an emoji. Like, you think dark matter's real. I think there's just a problem with the model. Like, what I should have said in the video was that if you think all of this is bunk and all these observations are wrong, that is a theory of dark matter. Because you're saying that you disagree with the observations and you're saying we just don't understand. And like, yeah, I should have said that in the video. Just that all physicists are liars or all physicists are stupid, both of which are wild to me. I don't know how to fix this. Like, I thought I clearly communicated, like, look at these interesting gaps in our knowledge. Isn't it fun? Isn't it fun that we don't understand? Isn't it a fun time to be in physics and we can learn new things? And they're just like, maybe there's a problem with the model. And like the problem I just spent 47 minutes highlighting and like going into deep detail? Yeah, that you did it. There is a problem with the model. You could call it dark matter. Is that what we should call it? I don't know how to fix this one because that's what I said, that this is the thesis of the video. And they're just responding that they don't agree with the video. They think instead exactly what I said in the video. I'm pretty bad at this. I know. I don't know how to fix that. Like, how would you fix this? Maybe this is inevitable. I don't know. Let's move on. Okay, so to summarize the dark matter video I made again, I made a video highlighting all the different observations of what we call dark matter. It's a dark matter problem. It's an open question that we don't understand. So scientists are like, look at this big open question. We don't understand this. We're calling it dark matter. Look at all these theories we have that we try to use to explain this problem, but none of them work. We don't understand what's going on. What a fun and exciting problem. Isn't it a great time to be in physics? And the next little pie chart, they called it a fudge factor. Dark matter is not a theory nor invisible matter. Dark matter is not invisible, it's dark. It is a fudge factor. Why don't you just say, I don't know? The trouble with scientists today is that they think they have an answer for everything they see. If they don't, then they fudge it. I don't think Einstein operated that way. Act like an adult by providing the right answer or no answer. That's what I said in the video. I was like, we don't know the answer. There are lots of theories, but none of them are good yet. We call this open question. Maybe I should have said that in the video. I should have said we don't have an answer. The cross-section might just be very small. It depends on what dark matter actually ends up being. Surprise, we don't know. It's an open question. What a fun and exciting time to be in physics. I mean, like, we specifically, no one is claiming they understand dark matter. Like, even the people who present their ideas are like, here's my theory, here's what I think, here are the flaws. No one's found a dark matter particle, and scientists are not pretending that they are. And yet so many comments call it a fudge factor. Do you guys know what a fudge factor is? Let me explain. The most famous fudge factor is one that doesn't actually exist. So Einstein wrote his general relativity paper, and it's supposed to describe the universe and how it moves, right? And he realized by like extrapolating his equations to like late times that the universe would like collapse on itself. And he didn't like that. He didn't like that. He wanted the universe to be kind of stable, just because. And so he added a little anti-gravity term, a little pressure term. And he was like, if you put this in the equation, the universe is a little bit stabler now, and I like that. But then before he published the paper, he was like, but I don't have any evidence for this. This is a fudge factor. He probably didn't say fudge factor, But you know, that's what it is. He was like, this is a fudge factor. There's no reason for me to put this in. So he took it out. And this is called Einstein's greatest blunder. Although I don't agree. It's not a blunder. Like, he didn't have an argument for why it should be in there. So he didn't put it in there because he's a good scientist. But anyway, now we observe like dark energy, a thing I don't want to get into in this video about dark matter because it's unrelated mostly. We see dark energy and people are like, this is kind of like Einstein's cosmological constant. Whoa, Einstein was a brilliant genius. He could see the future. And it's like, yeah, he was brilliant, whatever. But he didn't know about dark energy at the time, so he took it out. It wasn't a mistake. He was just being honest with himself as a scientist. And now we look back and we try to attribute him with like future knowledge. It's a whole thing, but that's what a fudge factor is. When I think of a fudge factor, I think of undergrad experimental labs. If you've ever taught one, you know exactly what I'm going to say. But like, imagine I'm teaching a lab and I'm like, hi guys, you're freshmen. We're going to measure G, acceleration due to gravity. Here's your equipment. By the way, the accepted value at our location is 9.81. So you have to get that, right? And there's a group who finishes their 2.5-hour lab in like 25 minutes. And you're like, guys, you can't leave. Let me see what you've done. And you check their lab report and they measured 10.2 meters per second squared. And then they calculated the error in their equipment and the statistical error. And they get like 10.2 plus or minus 0.2. And I'm like, hey guys, you didn't get the right answer. Because 10.2 plus or minus 0.2 does not match with 9.81. And they're like, oh, and they take their paper back and they add like plus or minus 0.4 human error. It's a human error. And they think that's a thing. I would call that a fudge factor. Because if the human has erred, you can simply do the lab again. And boy, did I get bad teaching reviews. I should have mentioned that in a video. Like, dark matter is not simply a fudge factor. There's a systematic human error or something like what the kids write in lab reports. Like, I hate to say it, but that's also a theory of dark matter. I should have mentioned that kind of thing in the video. But I guess what bothers me about these comments is that they don't even understand what a fudge factor is. Because scientists openly admit that they don't know what dark matter is. They're like, whoa, our model is wrong. There's something wrong with the model. This is not a theory. This is a list of observations we don't understand. A fudge factor is when you pretend to understand it. A fudge factor would be if you just looked at this and you just increased your error bars and be like, maybe our telescopes don't work so good. It's probably fine. That would be a fudge factor. Saying you don't know is how science works. Isn't that what you want us to do? You want us to admit when we don't know? That's what dark matter is. It's fun. It's a fun, open question. It's supposed to be fun. Oh, also, some of these call dark matter epicycles, which again, people are confusing theories with open questions, with observations. So epicycles are a theory for the observed behavior of Mars, right? Mars looks like it goes backwards. Is it Mars? It's Mars, right? Mars looks like it goes backwards, but really it's because of how orbits work, right? So the Greeks, they invented this theory of epicycles, like little orbits on orbits to explain the motion. And like, it's a really novel, cute idea, but it's wrong because like the sun is the center of our solar system. We're back at problem number one, that dark matter is not a theory, because epicycles are a theory to describe the observed behavior of Mars's retrograde motion, right? Dark matter is a problem. It's an observation that we don't understand, and there are 1,000 theories of dark matter that could explain it. But dark matter itself is a problem statement. It's not epicycles. It's not a fudge factor. It's an open question, and it's exciting and fun. Okay, so the final slice of the pie is teeny tiny. You could ask, why even put these comments into a category? And it's for an interesting data reason, which we'll get to. This piece of the pie is called aged like milk, which is a disgusting phrase and I hate it. Why are you people coming to my comments and typing aged like milk? Ew. I hope I've never said that. Are the kids convincing me to say aged like milk? I should title the video that. This video, aged like milk. Science communication fail. Hashtag fail. But I looked it up. Aged like milk is a quote from Jeff Dunham. You guys are coming to my comments and you're quoting the puppet guy? That's not even the best version of Puppet. I love puppets. Just watch the Muppets. Why are you guys watching Jeff Dunham? You watch Jeff Dunham and then you watch my video and you're like, haha, the dark matter problem aged like milk. Ew, I hate it. I hate it. But anyway, let's look at the data. So there's only 58 comments that say aged like milk, but there's something really interesting about them. So first, look at this plot of all the comments. So you can see you get most of the comments on the first day of the video, and then over time you get like 10 comments a day or like 4 comments a day. But do you see these little spikes down here? That's kind of interesting. They might not be statistically significant. So instead, let's look at a plot of the aged like milk comments versus time. Look at those spikes, baby. There's something going on there. That's an interesting data right there. Those are correlated to dates. And the fun thing about having a dark matter video is that every time dark matter is in the news, a bunch of people watch the video and then they're like, hey, your video aged like milk. Or they mostly say aged poorly or whatever. It's fine. So what's interesting about these peaks is that I know exactly what video they watched before they watched this video, or like what article they saw. So this first peak here is around the time when JWST had their first big data release, which means the first series of papers came out. And some of those papers were like, galaxies too small, galaxies too big. And of course, the media picked up on that and they were like, is the Big Bang wrong? Crisis in cosmology? Blah, blah, blah. So people like read those articles and then found my video and they were like, haha, the Big Bang is wrong. The next peak is associated with a pretty famous Mond physicist giving an interview that went kind of viral. He says Mond is real, and that kind of went viral, and people came to my video to be like, haha, Mond is real, which is again confusing because let me pause going through this chart here to tell you that the thing about my video on dark matter is that in this video, I am not a proponent of any dark matter theory. I just list the observations of dark matter, and any successful theory of dark matter must explain all of those observations because theories explain observations, and the observations alone are called the dark matter problem, but that's not a theory. You know what I mean? You get it. So if some Mond guy goes viral for talking about his new paper or whatever, his paper has to explain the observations in my video. So by definition, my video cannot age poorly because all I do is define the problem by listing the observations, and any theory of dark matter would have to explain all those observations. Do you see where I'm going? It can't. It's been crafted so well because I'm such a good science communicator that it can't age poorly because I don't advocate for any particular theory in this video. I just say any good theory would have to explain all these observations. Here's the problem statement of dark matter. It's not a theory, it's a list of observations. So that Mond guy is not in any disagreement with me. He sees the observation and he's trying to explain them with Mond, and yet people don't understand that. Me and that guy are both communicating. No, it's me. It's not that guy. It's me. It's all me. Because people watched my video, and even though I did not argue for any theory, because I called it dark matter, which is what it's called, I didn't name it, they think I mean dark matter particle, and that Mond can't be right. But that's not at all what I said. And I mean, maybe I should have talked about that. Maybe I should have said something about all the different theories. That might have helped. Tons and tons and tons of them is dark matter. A particle? Is it a superfluid? Is it Newton's law of gravity depending on R? It's like R squared plus a little epsilon or something, and who knows? Lots and lots of theories. It also goes back to the first problem about people communicating dark matter theories to the public, because there's so many different particle dark matter theories that just saying dark matter particle isn't nearly good enough to identify a particular theory. Like, there are so many that if I was talking to someone who worked on dark matter, we wouldn't say the word dark matter. They would just be like, I'm a WIMP guy or whatever. Do you know what I mean? It's like Dark matter is the name. It has nothing to do with what particle or if it's black holes or if it's MOND. That's just what it's called. I mean, if you don't like it, that's fine, but I didn't name it. So let's just go back to how my video can never age poorly, because it's just a list of observations. Keep thinking about that as we keep going. Okay, so this third peak here is a little like less easy to explain. It's an algorithm bump. Like people just all of a sudden started getting pushed my video by YouTube, and it was like in peak advertising season in like October, November. So that's just people watching it as if they had been presented it the first time. So that's related to this first peak here. And they're just saying like, oh, this video is half a year old and it aged poorly because remember that random JWST paper from 6 months ago? So that's what that is. This peak is related to a very much more popular than me science YouTuber who made a video that was like, is MOND real? Or I think I believe in MOND now or something. And my video was pushed after it. So people would watch that video and then they would comment on my video after not understanding what I said and being like, ha ha ha, MOND is right. This aged poorly. But again, I don't say MOND is wrong in that video. And I wouldn't say it now. I mean, I don't like it. It's not even close to a leading theory of dark matter. It's not the best, but I mean, it's not wrong. You know, it's a theory. It's fine. And my video doesn't go against MOND, so it doesn't make sense why they would write it aged poorly, because it's just a list of observations. I'm just defining the... It's fine. The last big peak here is the same thing. So there was a viral paper that was like, dark matter doesn't exist and the universe is way younger than everybody thought. And it got a lot of news play. And so people saw it and then came to my video and were like, haha, did you see this? Did you see this study? Let's just open the crock pot a little bit and I'll show you how the dip is made, okay? Because I think the fact that this happened so many times, I mean, it's only like 50 or 60 comments, so it's not that many, but it highlights a very, I think, prescient problem with how science works versus how science is communicated to the public. So here's what I think is what people think about scientific research that's not very accurate. They think a scientist does a study, they write it up, they publish it, it goes through peer review, and then it is a published academic journal article, and it is a golden statue, never to be touched. It can't possibly be wrong or not interesting or not useful because it's published. It's a paper, which is not true, right? What really happens is scientists, they do a research study, they write it up, they submit it for publication, it goes through peer review, and then it gets published, and then, you know, maybe it's just not very good and no one reads it. Maybe it's not interesting. Maybe it has a fatal flaw that the publisher missed. You know, maybe it's fine, but it's not the most interesting idea. People aren't excited to research it, and it doesn't really offer anything valuable or new, but it's just like, it's fine. Or, you know, maybe it's a groundbreaking work of research that is going to get lost and then rediscovered in 10 years. And everyone's going to be like, oh my God, how did this guy know? You know, all sorts of things could happen. Like science going from new to accepted by the entire community of science starts with publication, but it is not the end. However, that's not how the media presents it, right? The media is like, hey, we found that one guy published a paper that says dark matter doesn't exist and the universe is actually way, way younger than we thought. Let's just report that as if that's a fact now. As if scientists have to be like, oh, it got published? Oh my gosh, it must be true. I guess everything else is wrong. And it's just like, he got it published, so like I'm sure it has some scientific merit. But until the entire community reads the paper, redoes the research, finds that it's useful and valuable and interesting and it's a good explanation and it works with what we observe, it doesn't really mean anything is different. Does that make sense? So every 3 months when I get another spike of these comments that are like, this aged poorly, I have to put on my little Sherlock Holmes hat and try to figure out which random paper just randomly got pushed by the news. And now I have to deal with crisis and cosmology comments, you know? And this is actually why I don't ever talk about new science. I feel like it's hard, at least for me, who, is a failure and can't communicate science to save her life. For example, there was a paper that came out that said they had the first observation of dark matter stars. And that's what the paper says. And it went through peer review and it was published. Does that mean that that was the first observation of dark matter stars? I mean, maybe. Okay, so I'd like to talk a little bit about science communication, because you could go read this paper. It's a really nice paper. And honestly, I skipped the whole observations section because I'm a theorist and I love experiments. I really do. But when I'm reading all the technical details about the telescope and the images, and my eyes glaze over. It's really hard for me. I can listen to someone tell me about it, but I can't read this. I'm so sorry. It's a really vulnerable moment for me. It's fine. But I don't think you would get like all the background that I just gave you from this like little 4-page paper, because you kind of have to be in the field and know what's happening to discuss it. That's why science communication is so important. I can tell you why dark matter stars are interesting theoretical objects. And I can also tell you that this is not a discovery paper. We have not discovered dark matter stars. This is a possible candidate for what these objects are, which are currently unknown. That's why there's a little question mark in the title, right? Like maybe in 30 years, if we get our hands on some dark matter and that type of dark matter matches all the properties required for this dark matter star, and we have no other explanation for this observation, maybe in 30 years people would be like, oh yeah, that's the first dark matter star's observation. But we don't live in that future yet. We don't know yet. That's the fun of physics. We don't know if this is the answer yet. And I think when people do science communication and they report on new stories, new and exciting stories like this, they don't explain that. Because new science is like that. It's exciting and people have to do more experiments and they have to read it, and the community as a whole has to move toward like, this is a good explanation. And that's another thing that's very interesting about dark matter. There are 1,000 theories of dark matter, One of them could be right. One of them, like maybe the paper was published in 2017 and maybe someone's planning an experiment that's not going to be working until 2032. And then maybe it's not till 2041 when the entire scientific community is like, wow, that is the answer to dark matter. We did it. And in the future, in 2060, they'll be like, they found the answer to dark matter in 2017. Even though right now, that's not how we experience it, because science, it's really interesting. It's interesting how it works. It's a complicated process. That's why I like to talk about it. But that's the reason I don't talk about new research. I made one exception where I talked about how antimatter falls down, because of course it does. Of course it does. That was like a decades-long experiment and everybody knew the answer, but you still had to do it. And so it was kind of fun. And that's why I talked about that one. But if I was to do like a dark matter weekly report, and I read one of the many, there's 1,000 dark matter papers published every year, and I picked one of them and I read it and I commented on it on a YouTube video, my YouTube box would look insane. You would get whiplash. It would look like one week I'm like, dark matter's not real. And then the next week I would be like, the axion is the best particle for dark matter. And then the next week I would be like, MOND's coming back. Look at this new data. And it looks insane. But I mean, that is how science works. Like, it's not wrong. I find it complicated to convince the audience that just because a paper is published and just because it's making an argument, it doesn't necessarily mean that argument is right. That takes time. But that's also why it's fun. But anyway, my video is impossible to age poorly because I didn't fight for any specific theory like the coward I am. All I said was, here's all the observations. So, actually, got him on that one. But I think maybe in my video I could have conveyed this idea about science papers coming out all the time. Do you know what I mean? I could have mentioned something like the missing baryon problem, which is still a problem, and papers come out all the time. It's the missing baryons problem. Some people call them dark baryons, but that's confusing. Okay. Except, it's still a problem because the scientific community has not agreed that one of those papers was correct, that one of those answers is the answer. So people keep trying to figure it out, but we don't have an answer yet. But their papers are titled, "We Solved the Missing Baryons Problem," which I get can be confusing. But I probably should have mentioned something like that in the video. Okay, so let's wrap up. I was actually thinking about the aged poorly one. Like, my video didn't age poorly. It was immediately rotten because only 60% of the people who watched it understood it, which is such a bad ratio. This is pretty bad. Okay, so let's look at this plot again. 40% of the people who watched this video did not understand the text of the video, which means I'm a bad science communicator, right? I feel like, however, on the comments on this video, people might be like, no, like, those are trolls, or like, they would never change their mind anyway. And I think that's partly true. Like, a lot of these comments are people who are like, I haven't watched the video yet, but maybe you don't understand the definition of theory. And it's like, you haven't watched the video, but you feel like your comment will be useful? You feel like it's helpful? Like, why would you admit you hadn't watched it? Why would you leave a comment on something you're not gonna... It doesn't make sense, first of all. But the thing is that these people also exist in real life. I'm gonna tell you a story that's gonna make me look like an even worse science communicator, but this is a really vulnerable moment for me, okay? So I give a lot of public talks. Not as much anymore. People don't invite me anymore. I guess because I work in industry. That's okay. I talk about like galaxies, or I talk about academia, or I'll talk about like whatever they want. They'll be like, can you talk about space travel? And I'm like, sure, fine, whatever. And I make my nice little science talk, kind of exactly like these YouTube videos. And the thing is that these people go to the talks. And I'm going to give you an example, but I look like an asshole in the example. So I gave a talk on the first 3 minutes. You know, like, people talk about like the early days of the universe and what happened and what that means. And then I kind of wrapped it into like a Powers of 10 style video, like Carl Sagan, where you talk about scales and you go from like microscopic to macroscopic. I think it's a fine public talk. Like, it's a public talk. We're talking 6th grade education level, just like come and have fun and learn about science. And this guy comes up to me at the end with a smile on his face, kind of like those emoji commenters. And he's like, you know, I think scientists are full of crap. I don't believe in the Big Bang. Like, right, like in person, to my face. Like, I think you're full of crap. You're a liar. I was just like, oh, sorry you feel that way, I guess. But like, you don't have to come to this talk. Like, you are not being conscripted. Like, if you think I'm a liar, why would you come watch me talk about the Big Bang for 45 minutes? Some of these people leaving these very mean comments are publicly subscribed to me. Like, why would you seek out this information that makes you so angry? Like, if you think it's garbage, why? Why do you watch it? Why participate in science at all? It's such a devastating worldview to me. It makes me so sad. Like, I can communicate science all I want. There's just a fraction of people who exist who are like, I think you're a huge liar. You can't actually measure the density of Jupiter. So I say to this guy, I say, oh, sorry you feel that way. And I kind of turn, because there's always, people like talking to scientists. There's always like a line of people at the end, and it's always full of kids who are like, I want to meet a scientist. So I turn, because there's like a little girl there with like a NASA shirt, and I'm like, I would much rather talk to this girl than this guy who thinks I'm a huge liar and a phony. And he kind of like stops me, and he's like, you know what I've always wondered? And I was like, what's that? And he's like, does hot water boil faster than cold water? Like, that's what he asked me. And in my head, I was just like, really? You've always wondered if hot water boils faster than cold water, and you've never tested it? You've never had like 25 minutes in 2 pots to just test it? You've been so curious your whole life. You've always wondered. And now you're asking someone who you think is a liar to answer the question for you? Now, here's the thing. If he hadn't had started with the first part, I wouldn't have answered the question anyway, because I'm the worst. Like, if someone asks me a science question, I want to guide them to the answer. Like, the same reason I made this video And I was like, I'm not going to talk about any theories of dark matter. I'm just going to talk about the problem. That way people can develop their own ideas. It'll be so fun. People don't find me fun, actually. But if someone asks me, does hot water boil faster than cold water? Like, without doing the first part where they called me a liar, I wouldn't answer the question, but I wouldn't be mad at the question, but I would want to talk them through it. Like, why do you think it would? Like, what factors affect how fast water boils? What do you think? And I wouldn't give them the answer. Just like right now, I'm not going to give you the answer. I think that's a good way to communicate science. Because if I just told you, you wouldn't remember. But if I tried to make you think it through and work it out, you would remember forever. And also you would feel like a pride that you had figured something out, you know? So yeah, I'm a terrible science communicator. Don't ever ask me questions. But this guy, let's recap the story. He's like, I don't actually think the Big Bang's real. No, you're a liar. I hate you. And then I'm like, okay, sorry about that. And then he's like, here's a science question. And what I actually said was like, oh, you wouldn't believe me anyway. And then I pivoted. And that's mean. I shouldn't have done that. Like, I haven't improved the idea of a scientist to that guy. But, like, he called me a liar to my face with a smile on his face. Like, that's an appropriate thing to say to somebody. And I think this is why I'm not a good science communicator. Because, like, I don't really care about what that guy thinks. Like, yeah, I want to talk about science with people, but not to that guy. Should I have to talk to that guy? He called me a liar to my face. I would much rather talk to the little girl with the NASA shirt, right? And I feel like if I was a good science communicator, I would find value in trying to convince the people who hate us and think we're all liars that you shouldn't and we're not lying. But, like, that's not what I want to do. I will say it's not all doom, because a lot of these comments were people who definitely understood the video, and that's really nice. Like, people were like, oh, this cleared up something for me. And I'm like, oh, thanks. That's perfect. That's what I wanted. There were even a bunch of people who were like, oh, I didn't know all those other observations. I still like Mond, though. And, like, that's totally fine. I think this plot is shocking, and I have sent it to all my dark matter friends. But, I mean, it's fine. Like, you can like Mond. It's totally fine. People do. Not a lot of people. But, I mean, they exist. But there are also a bunch of people who understood the video and then see the comments where people are very confused and they're trying to explain it. Like, they're communicating, like, the thing they missed. And I think that's really hopeful, because even if I'm not going to talk to the guy who called me a liar to my face, there are people that exist in the world who will. I am a failure at science communication, but that's okay, I guess, because I'm not considering myself a science communicator. I'm just telling fun science stories on the internet. But isn't this embarrassing? That time I tried to do it, just completely with my whole heart, earnestly trying to be like, I think dark matter is really cool. Let me describe the problem to you. I think it's so fun. And everyone was like, have you considered the model is wrong? And that was the thesis of the video. The thesis of the video. But okay. So, it's not a theory. Dark matter is a list of observables. We see it in velocity. Now you understand why we see it here in this plot and here in this plot. Tell your friends. goopy,